Right, here we are at the Farnborough International Airshow 2026, and I am with Karen Salmon from Force Technologies. And this really is Karen's stomping ground because so much of this company's technology is involved in the aerospace industry. So I'm going to ask Karen, why are you here and what's the story?
Well, nice to see you again, John. Yeah, it's a great day. It is our stomping ground. Aerospace is our business. I think I've said to you before, RAF family. So a lot of the airplanes here have been in our family for years. But primarily, we're here to just catch up with customers. We're here to see some of the big guys that we sell to, the Leonardos of this world, the Boeings of this world. That, they're here talking about air structures and propellers and everything, but the tiny little electronics in the aircraft that make things happen is what we make. And as you see, some of these aircraft here, I don't know if you've had a chance to wander around, are quite old, so they're legacy products as well. And then we're here for the air show this afternoon. I brought a couple of my guys with me. We're here to see the Eurofighter in particular. We've got 25 FT products on the Eurofighter. Okay. So things like the warnings panel that comes up for the pilot, the head-up display. More importantly, one of our chips helps the air circulate for the pilot, helps him breathe. Yep. So that's quite important. Yep. And also for the wheels to go down. So I'm really proud. I've followed, Eurofighter was one of the first things I worked on when I first started in the industry. Whether it's 40 years ago, I sold parts to Litef and General Dynamics at the time. So I've watched the Eurofighter travel. So it is my favourite. I was here yesterday when it took off at 3 o'clock. Oh my gosh. For a girl who was just aeroplane mad, it was a fantastic, I was just shivering. So hopefully we'll see it again today. I think it's 4 o'clock. But it's just nice to catch up with people. A lot of people are here. You guys, I'll probably see Luke later on from Rochester. Some of my Italian distributors here as well. So it's a great event, and there's a lot of money here, a lot of money, and a lot of good projects.
Well, I saw the news yesterday. Lots of orders signed for civilian and military projects, I think. One thing I was going to say, a lot of the stuff we're seeing on the stands, lots of sort of unmanned vehicles. Yeah. I'm assuming there's going to be a whole bunch more electronics in those, quite sophisticated stuff. So I guess you'll start to look after that type of product in the near future.
Yeah, and obviously where I'm from, Wiltshire, they've just opened a big drone factory in Swindon. We will start to see that coming through, but more because of allocation. So the drone manufacturers are really going for it. So they're going to take up, a bit like AI, they're going to take up a lot of the allocation of the electronics that people use now. So obviously our long-term storage will be getting busier because we'll have to start stocking this stuff for these drones because they've got to last. But also the counterfeit's going to come back. And I've talked about this with you before. As the demand goes up, when the industry can't cope, then the counterfeiters will come in. Yeah. So obviously that's where the sovereign test lab comes in. So the drones, although it's a good thing, I think it's going to have quite a marked effect on the aerospace industry and supply. Yeah. Maybe not for the best. Yeah.
And you mentioned there when you first took a look at Eurofighter, you say 40 years ago. Yeah. So that gives our viewers an indication of the sort of time frame over which you guys operate. Yeah. That's effectively 2 generations of engineers have gone through, and those components are still in demand. Yeah.
I mean, the first thing we did is when they first did it, on the warnings panel, it was 2 companies. It was Germany and Computing Devices at the time. Okay. And it was very frustrating because Germany, but on one side, we used the R8000, and the other side uses the MIPS chips, these Computing Devices, and trying to work that one on. Yeah. But a lot of that stuff was Atmel, and I designed a lot of Atmel stuff into there. I think the first thing we designed to UFA was an E-squared, and we still build that E-squared, scarily enough. And there's now General Dynamics, and then Litef broke away. But yeah, it's still going, and the upgrade. The thing is, a lot of people, when they're upgrading and they're doing new Tranche 1, Tranche 2, and it was the same with the Tornado midlife update, they just look at the structure and the airframe. They want to make the plane lighter. They want to make the payload, heavier. They want to make the missiles easier to maneuver. But what they do forget is that electronics do change as well. Yeah. And then before you know it, they've got all the nice fancy airframes and propellers and all that kind of stuff. But oh my God, hold on a minute, we haven't got the chips to make it work. and that's obviously where we come in.
Yeah.
So we try and keep an eye on it.
So it's an awareness thing as well, I guess, keeping those engineering teams aware of the fact that the electronics need to progress in tandem with the airframe and everything else.
Yeah.
So fascinating. Well, it's looking like a really busy show.
Yeah.
We're certainly looking forward to the air display this afternoon as well. I think it starts around about 2:00. So I'll keep an eye out for the Eurofighter.
Yep.
We should have some of your parts airborne and in action.
Yeah, most definitely. Yeah, very
brilliant.
exciting.
So good to see you again.
Yeah,
and have a good show.
Yeah, take care.
Here we are at the Farnborough International Airshow 2026, and I'm with Chloe Boswell from Retronix. And I'm going to open this conversation with a really simple question for you, Chloe, which is, what sort of challenges would companies in the aerospace and defence industry be facing for Retronix to be the solution?
Okay. So that's a very loaded question because it's all of our services. So what Retronix, the two main parts of the Retronix business, I would say, are alternative alloy conversion and end-of-life design stability. So what that means for customers in the high reliability sector is we are that solution for customers who cannot get the parts that they require for their bill of materials and the alloy that they need.
Right.
In the aerospace and defence industries, the predominant alloy that they use is the leaded alloy, but due to ROC compliance, parts are not manufactured in leaded anymore. So what Retronix does is offer a solution to those companies who require that for those builds, because we're able to take their parts for them and do alternative alloy conversions through our services, whether that's retinning or our laser reball or reflow reball services. On the other side, the sustainability side, you've got end-of-life design stability. So there's a lot of market challenges that we're having right now, shortages, parts are obsolete, or customers are just facing a huge lead time on parts, or they're very expensive. So what Retronix services can do, again, is we can offer a solution in that we recover parts. So those parts that they've already used, so it's existing parts, maybe they have bone piles of scrap boards, and they've identified that rather than just scrapping the boards whole, there is high value, authentic components on those boards. So Retronix offers the solution that way, where we can, again, utilising our services, safely recover those high value components, refurbish them, and send them back to them for reuse in their manufacturing supply chain, or it could be for reuse and repair, or we can also offer another arm for them where we can liquidate the parts for them as well.
Okay. So on the alloys, that's an interesting one, because the whole sort of lead-free thing's been going on for quite a while now.
Yeah.
For aerospace and defence, I guess it's a reliability, high-temperature operation, that type of thing require that.
So for the leaded alloys, it's more durable, so it prevents the phenomenon called tin whiskers.
Yep.
So they're exactly what they sound. They almost look like cat whiskers.
Yep.
And they grow on components if they're faced with extreme pressure. So there's nothing more high pressure than your space and your defence kind of industries. So these tin whiskers will grow on the lead-free alloy, but you can't see them. They're invisible to the naked eye. So what will happen is they cause shorts, and it causes the components to fail. So that is why in these high pressure, high reliability industries, they prefer the leaded alloy because it prevents tin whiskers. It's a higher quality and it's more durable.
And in terms of the component types you can handle, can you go from sort of through-hole leaded to surface mount, leaded to ball grid arrays to,
So we've done actually for a very large defence customer just in the last couple of years. We did a full bill of material conversion from the lead-free alloy to the leaded. So there isn't a component that we can convert for a customer. There's some absolutely we prefer more than others, but there is definitely not a component that we wouldn't be able to convert for them.
Okay. And in terms of the sort of product life cycle, with the component recovery, again, any limitations in terms of the boards and components that you can work with?
Definitely no limitations. I think for the customer it will be what's the value in the recovery. The value in our recovery process obviously is it's allowing customers to reduce their scrap, become more environmentally friendly. Everyone's asking companies to be more sustainable these days, and that's giving them a way to do it. But there is also a cost implication for the component recovery. Yep. If you can buy a part, say at $1 brand new, there isn't really much point coming to Retronix and asking to. So that would be the only kind of arm that you could view it wouldn't be worthwhile recovering. However, there is components which we can recover for, say, $100, or we have in the past. I'm talking from experience, $100 that are $50,000 to buy.
Right.
There's components that we have taken away the monetary value. There's components that we could process and rework for customers in 15 days, whether if they were wanting to buy them new, you're probably talking a 22-week lead time. So there's definitely, depending on what application it is and depending on what component it is, and the customer as well, there's different avenues on why the component recovery would be useful to them.
Yes. So it could be cost related, it could be availability, it could be time scale, lead times.
Or just like what we're seeing today, like Retronix is blown up with memory recovery, because you just can't get memory devices today. So it's shortage driven as well, so the market really helps in times too. But as you say, it's mostly cost, availability, lead time.
Brilliant. And how's the show itself? How have you been getting on so far? Been busy for you?
Yeah, the show's been great, really busy. Again, a lot of customers in both arms of Retronix. You've got the main ones, obviously, are the high reliability, our aerospace and defence customers. But we are also speaking to a lot more companies now about end-of-life design stability, which is something that they probably would have considered maybe 10 years ago. However, due to market challenges, it's something that, is in maybe the back of their head now that they have to consider. It's just giving them, previously companies were just relying on, franchise distribution, and now that Retronix is giving them a way for alternative supply chain solutions.
Yep.
So it's really good. Retronix are also working with IPC on creating a standard for reclaim, which I think will bring that to the forefront of what we're trying to do here. It'll allow customers to see, this is an accepted practice because there is an IPC standard for reballing and retinning. So hopefully this repair and reclaim standard will allow customers to see that it's an accepted practice. It can help them become more sustainable, and it can also help overcome some of the supply chain challenges that they're facing.
Have you got a time scale on that? Do you know when that's likely to be available?
First draft hopefully should be ready by about Q3 this year.
Okay.
And we're hopefully the draft it'll be available towards the end of this year, and then it can go to full production for next year.
That's interesting because there's a lot of legislation with sort of right to repair, certainly in the automotive industries and things like that. So that should help feed into that, I guess.
It should definitely help feed into it, because a lot of customers, like you say, there's a lot of legislation, but there's just a lot of companies who would consider it taboo. They don't want to look at it. But when something like COVID happens and they have no other solutions, it's something that they do consider. It's something that they did work with Retronix on, and we've proved that it is reliable. And we're giving them parts back that are just like brand new parts. So it's definitely going to give them that that fuzzy feeling, that it's backed by this standard. It's an internationally recognised process. So I think that will just help in Retronix's efforts to offer different supply chain solutions.
Yeah, so confidence in the process and trust in your brand.
Yes.
Yeah, brilliant. Well, I think that brings us to the end of our chat. That's been fascinating. I trust you'll have an excellent show, and we'll certainly keep track of your ongoing activities, and in particular be back to talk to you when that standard emerges.
Yes, absolutely. Thank you for having me.
That's right, here we are at the Farnborough International Airshow 2026, and I'm on the Wales stand, and I'm with John Dyson from Winslow Adaptics. We're going to find out why John's here and what he's been up to. I think I know, because a lot of their technology is used in the aerospace and defence industry. And then we're going to talk about a vlog that John has done recently in a rather unusual location. But let's start. John, why are you here, and what are you hoping to achieve?
So we're here, as you quite rightly said, because we have so much technology in aerospace and in defence, primarily to catch up with our customers and our partners and our suppliers, because nearly everybody we deal with, one way or another, in this sector, is in this room here today in Hall 1 of the Farnborough Airshow.
Yeah, fascinating. So it's a microcosm of everything in this one hall.
It is literally. I can't walk 100 yards without another face, that I know from somewhere. And
give us a clue of some of the technologies that would be in here that would be of interest. So some supplier and some customer. What's the sort of technologies?
I think. Well, it's all about, for us, in this sector, it's all about semiconductors, and it's all about obsolescence. So it's a huge problem when you have an asset that's worth millions of pounds that has to run for 30, 40 years. It's a huge problem. Obsolescence will come around many times, and it's really where we focus on our adaptic technologies. That's where the Adaptics comes from in the Winslow name, and where we can adapt the new semiconductors to fit on the old circuit boards with the minimum of fuss and the minimum of re-qualification.
And I often ask the question, have we reached peak obsolescence, or is there still way to go?
No, because do you know what? Peak obsolescence will be when the AI boom crashes. Because they all need new equipment. And that will be the boom of obsolescence, I think.
Yeah, I read somewhere that a modern data center has a sort of design life of about 4 years. So, there's going to be a bit of turnover of technology there.
I think that's almost inevitable. We're seeing breaching the stratosphere with the increase in the number of components that are being manufactured and the price that they're actually being sold. If you look at things like the memory market, going absolutely crazy, like we've never ever seen in the last 50, 60 years. Wow.
Yeah, so some world firsts for all the wrong reasons.
Absolutely, world's first for all the wrong reasons, and hopefully, we'll be there to pick the pieces up when it all goes wrong.
Yeah, brilliant. I'm sure you will. And then, just for the second half of our conversation, I watched a vlog that you and your team made recently that we want to direct our viewers to in a rather unusual location, because vlogs are normally in nice office surroundings with plant pots and things, but this one was somewhat different. So tell us all about the logic. Well, tell us where you were and then the sort of logic behind that vlog.
Okay, so we were in Charing Cross Tube Station. Nothing unusual about that, you think? But actually, this was Charing Cross on the Jubilee line, which doesn't actually accept passengers anymore. It was made obsolete many years ago when they extended the Jubilee line eastwards to actually connect up with the Docklands. So we were able to, through some very, very good friends of ours, we were able to get access to this station, which is just used for. I don't want to tell you all of the plot lines, but it's just used for films. It's used for things like engineering testing and various other things. And indeed, as mundane as parking a tube train if they got too many of them at lunchtime. So yeah, we were able to get access to this to actually run one of our vlog episodes. Which is now actually published, finally, after about 3 months.
Well, we'll direct our audience to that vlog so that they can have a read of that. Yes, down there. And yes, so that's one of those sort of notorious, almost ghost stations that we hear about that you can never imagine really exist, but they do exist.
Yeah, it's fascinating to be down there because you go to a tube station and you expect to see people. So I went down, with Terry Ann, and there was just nobody there. There was absolutely nothing. There was no noise. There was nothing. Yeah. And that's such a surprise. Yeah. It was eerie. Yeah.
Excellent. Well, you always surprise us with your vlog locations. So we look forward to the next one, wherever that may be.
The next one has actually been recorded already. And it follows on, I think, it's fair to say, from what we did at Charing Cross.
Well, thank you very much, John, for that brief chat here. We trust it will be a busy show for you, and we'll leave you now and let you crack on.
Thank you. It's been great to catch up, John.
And here we are at the Farnborough International Airshow 2026, and look who I've bumped into in the aisle. It is Luke Fitzpatrick from Rochester Electronics, and the last time I think we were talking was on a podcast at your HQ a few months ago. So this obviously, Luke, I think you look after the aerospace sector, don't you?
That's
for
right,
Rochester.
Aerospace and Defence for Rochester and EMEA. That's right. Yeah.
Yeah. So this is your kind of zone. So tell us what's happening. What's going on at the show? What are the trends? Where do you fit in? Who are you talking to?
Very much so. So you're right. Yes, this is our very much our place of work. This is very obviously the show is very system platform level. We operate at component level.
Yeah.
But obviously, if you look at the investment that we've seen just on the first day in terms of the engine orders and the platform orders that we've seen for the different aircraft, it's going to extend the life cycles, or extend the order books, I should say, of those platforms. And when order books are extending, that means that the electronic systems within, obviously the life cycle has to extend. A lot of those last time buys on electronic component level have already been done, and so for them to extend those platforms, they're going to need support, and that's where Rochester comes in.
Okay. And in terms of orders placed here today, when will those aircraft be delivered? What's the cycle of that process, and where do you drop into that?
It depends on the platforms, but if you're looking at, let's just say the A320neo, which I think we had some orders for yesterday, you're probably looking at a 10-year backlog, if not more.
Okay.
So in terms of when we get involved, that's down to the OEMs and the tier ones in terms of how, when they want to secure that solution for the future. Many of them will actually say, okay, we've got further backlog now, so we want to secure out another 2, 3, maybe 4, 5 years, and therefore they'll invest in the solutions today to secure that pipeline into the future as much as they possibly can.
And in terms of the solutions you're talking about, how do they kind of get packaged up? Where are you getting those components? How are you storing them? Are you remanufacturing them, re-engineering them? What are the channels they're going to be using?
It's all of the above.
Okay.
It's all of the above. If it's a solution whereby we've already got stock and we already had to invest in the finished product, then will be a stock solution. If it's a component where we took on the original license to manufacture that product into the future, then we'll be manufacturing those parts for the customer to put into their last time buy allocation or whatever it is that they have. Then if there's a part where we don't have the license in play and we don't have the finished product, then we'll engage the design team to potentially replicate or clone the original device to continue to then manufacture that for the future for the customer. So it depends on the reasons of obsolescence and what stage in the life cycle it is, and how old and when the product actually went obsolete.
And just to give a gauge as to the entire life cycle, if it's 10 years to get from an order being placed to delivery, how long is that aircraft going to be operational? And what does that make the total life cycle of that product that you would be supporting?
That's a great question. It depends on also the system level. It depends on the type of system within the platform. If you're saying it's like an avionics or a cockpit or radar, let's use radar as an example. Radars are updating on a very consistent basis every sort of 5-10 years. So the OEMs or the tier ones will be wanting to update that product and sell it into the platforms. So the life cycle on those might be shorter. Now, if you're looking at a system which is in the wing of an aircraft on a refueling panel, there's no need to fix that system. There's no need for it to be redesigned. They just want it to do the one job for the whole 40-50 years life cycle of that aircraft. So in terms of the system level, black box level, it depends.
If I'm just looking at my watch, I think that's the F-35.
It's the F-35 indeed, yeah. We've got a few products on that as well.
Oh, brilliant. Excellent. So great to speak to you again, Luke, and have a good show.
Excellent.
Cheers.
Good to meet you.